Hi, I'm Paul Battaglia, and this is section 4.6. Students enter 4.6 having knowledge of some basic integration rules. Now they have a better idea of using a more complex strategy in integration by substitution, and it's time to expand the inventory of functions that they can integrate, namely some rational functions and the other four trig functions as well. So the essential question we would like students to be able to answer at the end of section 4.6 is, how do I integrate some rational functions and the other four trigonometric functions? I think what's really important right off the bat to stress to your students is they must be able to memorize all of their trig integrals, just as they had to memorize all of their trig derivatives. That being said, there are a couple of examples we should go through. Specifically, let's look at log properties that might be used. You may find that you have to review some of these properties with students. I'll give you an example. Let's say we were doing the integral from 1 to radical e of -7 over x dx. Now, once students go through this and apply the fundamental theorem, they might get a whole host of different answers. See what you get. You may get something from very basic, -7 ln radical e plus 7 ln of 1, to a couple more simplified answers. But do any of the students know that that answer could actually be reduced all the way down to -7/2? Why? Simply because we've used log properties to do it. Now, the feedback you're going to get from some students is, well, do we have to simplify that far? And my answer is always the same. Why wouldn't you want a cleaner answer, number one? Number two, don't you think it's more logical to expect to see that kind of an answer, -7/2, on any assessment I give you, let's say in a multiple choice question, or one that the AP exam presents? Definitely. Here's another integral for students to look at, and the reason I like this one is because it addresses mathematical practice number 3. Students need to be able to select the appropriate strategy, especially when integrating. Give them the integral of the quotient of sine of 2t plus 1 in the numerator over cosine squared of 2t plus 1 dt. Now, because we are where we are in section 4.6, sometimes students become creatures of habit. They think, well, I see a quotient of two functions, so there's got to be some way that this will result in a natural log. This is natural. What you want to do is stress to students, we can't forget earlier things that we've talked about. In fact, one of the early things we said in section 4.1 was, how about the option of rewriting the integral? Now, if students do that using integration by substitution, they would arrive at the integral -1/2 times 1 over u squared du. Take a step back for a minute, they'll realize, wait a minute, that wouldn't be the natural log. We can just use the basic power rule. We can rewrite that. Make it -1/2 u to the -2nd power, and then integrate from there. This is the kinds of things that really students are faced with. They have to select the correct strategy, and that could change from problem to problem. Now, another common mistake that student might make, maybe either in their assumption or in the computational process, is seeing 1 over u for the first time and saying, oh, well, you know what? I'm going to make that u to the -1 because I know how to rewrite things. Let them go through the process. Let them fail with that example. Because what will happen is they would get u to the 0 over 0. Some students might even make that 1 over 0. Give them a minute, and then they'll realize, wait a minute, I can't do that. And that's, again, the need for them to recognize, no. 1 over u in the integrand, that's where we need to invoke the natural log as a result. Now, that being said, on the AP exam or on your assessments, it's just so important that students know that, yes, memorization is sometimes important, like it is with these integrals, but it's being able to employ the correct pattern, the correct strategy at the right time. It will carry them forward. See, now that they know a bigger inventory of functions to integrate, wouldn't it be logical for you or I to include more real-life problems that include those kinds of functions? Sure it would. So students need to understand that this is maybe what's coming. I hope you found these tips helpful. I'm sure you'll have much success in section 4.6.